recording. Is there anyone who does not yet have their Unit 4 workbook? Everyone has it? Okay, good. Oh, yeah, it's over on the side. Underneath the periodic table. Yeah, you don't want the grade 12 one. So, what's going to happen is on your cover page, you will see it says things like, when you do 4.1a, there is a quiz associated with that. Okay, so once you finish 4.1a, you are ready for quiz number 1. Once you finish 4.1b, you are ready for quiz number 2. And once you finish 4.1c, you are ready for quiz number 3. Now, once you finish 4.1d, you're not really ready yet for quiz number 4. And do you see how it is not bolded? It's like italics. That means you need to keep going. Yes. And when you get to 4.1e, you will be, oh, why? That's not a highlighter. That makes me sad. Okay, hang on. Highlight. Oh, there we go. Okay, when we get to 4.1e, you will be ready for quiz number 4. Okay, now, what the heck is 4.1f doing there? Well, 4.1f is because 4.1e is sort of like quiz number 4 is one of the more challenging quizzes because it does require you to figure out the Roman numerals. Okay, so if you need some extra practice after you've done quiz number 4, like let's say you got 3 out of 6 and you're like, oh, I don't like the looks of that, I would like to have a better grade than that, then you can do 4.1f. Okay, does that make sense? And then I don't even know if we need 4.1g. You're welcome to use it if you want to, but you don't have to. Does that make sense so far? Okay. Now, where will you be getting these quizzes from? What you're going to do is when you are ready for a quiz, you're going to walk to the back of the classroom. Okay, there is a little black box here, and there is a purple box. The black box contains quizzes 1 through 7. The purple box contains quizzes 8 through, well, actually through 15, but you're only required to do up to quiz number, I believe it's 11. Everything after 11 is enriched. Okay? So, let's say you are ready to write quiz number 1 because you're like, I don't even need to study for that. As long as I have a periodic table in front of me, I would be able to name compounds like NaF, CaO, Al2, N3. They're all going to be ionic compounds. As soon as you're ready to write that, you can write quiz number 1. Now, when you're ready to do that, you are going to take quiz number 1A. 1A. If you don't like your mark out of 6, you can do a little extra practice or just figure out what you did wrong, and then you can write quiz number 1B. Okay? Now, let's say you finished quiz number 1. You got 6 out of 6. You're not going to go write quiz number 1B. You're going to write quiz number 2A. So quiz 2, there's version A, B, C, D. Quiz 1, there's version A, B, C, D. They're there for you to practice if you need to. Okay, 3, there's A, B, C, D. And I do need to explain this to you because you guys did not grow up with the wonders of the card catalog system in the library. Back in the olden days when I was a child and a teenager, when you went to the library, you had to go and look up by author. There was this huge thing and had all these drawers and you would pick the drawer with the right alphabet, and you would find the letter of the alphabet, and you would go in behind the tab. So if you want quiz 1A, you don't go in front of 1A, you go behind 1A. If you want quiz number 1B, you go behind 1B. Now, if you get it wrong, because somebody's going to get it wrong, because, you know, whatever, you forget, it's okay. Don't worry, I'll just be like, oh, you probably didn't mean to do that quiz, you'll need to do this other one. Okay? Now, whenever you're ready to write a quiz, you can write it. The only thing is, if I'm teaching something and you haven't learned it yet, you should probably pause in your quiz writing and pay attention to whatever's going on if you don't know it yet. Okay? Your goal, I'm gonna set you some goals. Quiz numbers 1, 2, and 3 should be done by Monday. Okay, on Monday or before Monday. And if you're like, what? What? Let's just look at how easy quizzes 1, 2, and 3 are. So let's start by going to 4.1a, which is on page 10. In fact, you already know how to do these ones. Yes? On page 10, we have ionic compounds. And how do you know that you have an ionic compound? What does an ionic compound begin with? Yeah, ionic compounds begin with a metal. Now, I'm going to put in here in brackets or NH4, but you won't come across that yet because we're not doing polyatomic ions yet. Okay? So for this particular worksheet, it's just going to be a metal. So there's a lot of blah, blah, blah here. They form crystal lattices. That's nice. Why am I calling this section binary compounds? What does the prefix bi mean? Bi means 2. So how many elements make up a binary compound? 2 elements. So a binary compound has 2 elements. And if it is binary ionic, the first element is going to be a what? Metal. The first one is going to be a metal, and the second one is going to be the non-metal. So binary ionic compounds, metal plus non-metal. And you were actually practicing naming these when you were doing Lewis structures of ionic compounds. Yes? So here's a sodium chloride. Sodium gives its electron to chlorine, there, chloride. So now we have a sodium ion. And we have a chloride ion. And so what do we call that compound? We call the compound sodium chloride. So the only thing you have to remember about these ones is that you change the ending of the non-metal to ide. Why does only Sky know this? When you have a metal and a non-metal, we change the name of the non-metal to ide. So that's the second word. Second word, ide. Do we change the first word? No. Anyone ever heard of sodium chloride? Nope. Okay. I've heard of it because I get all kinds of weird stuff on grade 9 quizzes, but all right. So the cation stays the same. The anion changes to ide. watch out for fluorine. It will appear on every version of quiz number 1 because I want to make sure that you can copy down the spelling. It is UO, not OU. Fluoride, not fluoride. Yes? So watch out for fluorine, which becomes fluoride, FLUO. I think you guys are probably okay with this, but just in case, if you've done some of your studying in your home country in a different language, you might not be as familiar with these. Does oxygen, tell your partner, does oxygen become oxygen or oxide?
Oxide.
Oxide. Does nitrogen become nitrogide or nitride? Nitride. Does phosphorus become phosphoride or phosphide?
Phosphide.
Phosphide. Does hydrogen become hydrogide or hydride? Hydride. You'll notice that we use only the first syllable. Yes? So just the first syllable plus ide. Yeah? First syllable plus ide. So you'll always have chloride, 2 beats. Phosphide, hydride. There's only one that doesn't do it. It's selenide, and I won't give that one to you. Okay? The only other thing to point out is that sulfur can be spelled sulfur, and I'm okay with you spelling it either way. That means it would become sulfide or sulfide. Is good? Okay. So there's some practice here. You'll do that over the weekend. All right, we're not going to stay there though, because that should be really easy for you. Now, we have more binary compounds. How many elements are these binary compounds made of? 2 elements, but in this case, and this is on page 12, binary molecular compounds are made of a nonmetal plus a nonmetal, so 2 nonmetals. Binary compounds are made from 2 elements. Covalent bonds form when elements do what with their electrons? Share. To get a full shell of 8 electrons, or how many for hydrogen? 2 for hydrogen, and that is a very stable. Between what types of elements do covalent bonds form? Non-metals and non-metals, also metalloids. Or metalloid. Or metalloid. When these non-metal or metalloid elements bond covalently, they mostly form little clusters of atoms that bond covalently. What do we call those little clusters of atoms that are bonded covalently? Molecules, yes. So, because we have covalent bonding and because they are molecules, we can actually have 2 different names for compounds made of nonmetals. We can call them something compounds or something compounds. Can you guess what they are? Covalent compounds or molecular compounds. Now, when the atoms in a molecule are the same, we have a molecule of an element. When we have different types of atoms, we have a molecule of a compound. Yeah. Now, do you remember I gave you some prefixes yesterday or the day before or something like that? Okay. In this document, we're going to be naming compounds only. We're not going to worry about the elements because they're too easy, because hydrogen is just hydrogen, right? We are actually going to skip this page because I don't think you need it. Skippity skip, skippity skip, 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 skip. If you want to go back and do that, feel free. I've got it there because I use the same document for my grade 9s who've never seen this before. Okay, so they need more hand holding. Page 15. So, the first element, you just named the element's name. No-eyed. Is that any different than ionic? When we name the first element in an ionic compound, do we change the name to "ide"? Nope. And even though this is a non-metal, we don't change its name to "ide" because it is the first element. So no "ide" for the first element. But what about the second element? Change it to "ide." Okay? So second element changes to "ide", first element does not. And hopefully from grade 9 and 10, you remember that the prefixes are used to tell you the number of atoms of each type. Okay, so mono tells you there's one atom. Di tells you there are two atoms. Now here are the tricky ones, number 4 and number 5. These are the only things that make this complicated. Mono. No mono on the first element. Yes, mono on the second element. That doesn't apply to any of the other prefixes. All the other prefixes go on both the first and the second. And lastly, yeah, you can just toss it in there. Lastly, if you have an O or an A, let's look through our prefixes and see which ones end in O's and A's. Mono, tetra, penta, hexa, hepta, octa, nona, deca. Those are all the ones that end in A. Di and tri do not end in A. You will drop the O or the A, but only before who? Oxygen or oxide, not before anybody else. Yes? Do I have a what? Song. A dog? Song. A song. I do not have a song. If anyone would like to come up with a song over the weekend, I can give you some bonus marks. Yes. All right. I wish I had a song. I have a song for almost everything. I need a song. Oh my gosh. Mono is used on the second element, but not the first. But not the first. And okay. We got to work on this. That was bad. Okay. So you need to memorize this chart by Monday, because on Monday you will be expected to be able to name these compounds. Yes? So there's a bunch of practice here. So just so you can take a look, here are some examples. Never drop the I's. Dioxide. Don't go doxide. That's just weird. Trioxygen does not become troxide. That's just weird. But if you do have pentaoxide. We don't do that. We just call it pentoxide. We don't say monoxide. We say monoxide. Okay? And you'll notice what's missing here. I have one carbon and I have one oxygen. Mono goes on the second word, telling me I have one oxygen, but does it go on the first word? No. Is there anything here that you've never learned before? No. And then finally, so I'm going to let you practice those over the weekend. You still need to know your prefixes. You need to recognize whether a compound is ionic or molecular covalent, because then you're going to have to say, I'm going to use the prefixes when it is covalent. I will not use the prefixes when it is ionic. So actually, right up at the top of this one, ionic, no prefixes. Covalent, prefixes. So anytime you have metal plus nonmetal, anytime you see a metal, these ones always start with metal or who? Ionic compounds start with a metal or what ion? NH4 plus. Okay, but you won't see that yet because we're not doing polyatomic ions just yet. Metalloid plus metalloid gives you covalent. Metalloid plus nonmetal gives you covalent. Metal plus metalloid. Oh, look, we have a metal. What kind of a compound do we have? Anytime you see metal, that tells you it is ionic. Okay? Ionic, do not use prefixes. Covalent, molecular, do use prefixes. It reiterates no mono on the first word, mono on the second word. All other prefixes on both words. Drop the O and the A before oxygen or oxide. Blah, 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 blah. You can choose either molecular or covalent. If you prefer covalent, you can put a C instead of an M. Okay, so you get to decide. For example, is this first compound on page 18, is it molecular or is it covalent? Or sorry, is it covalent or is it ionic? Phosphorus and oxygen. Phosphorus is a nonmetal. Oxygen is a nonmetal. Therefore, this one is covalent. So do you use the prefixes? Yes. By the way, these compounds, a lot of them are impossible. You guys have just done Lewis structures. You're going to look at it and be like, you can't make that. It doesn't work. I know that. I'm just giving you a whole bunch of like compounds to have you memorize the prefixes, right? So do you remember the prefix for 4? Tetra. So you would say tetra what? Tetra phosphorus. And then what's 6? Hexa. Now, is it hexaoxide? Remember, in front of oxygen, what do you have to do? Drop the A. So it just becomes hexoxide. You would get a half if you didn't drop the A. Okay? I'm not sure how long this class is. I know we don't have a lot of time. We might be almost over at this point. So we go to 12. We go to 12:40.
Like lunch is at like 12:40.
22. Okay, so we got like 5 more minutes left. So basically, your homework is to do 4.1a, check your answers, 4.1b, check your answers, 4.1c, check your answers, and be ready to do quiz 1, 2, and 3 on Monday. They're all only 6 questions long. And as you can see, some people are already like turning them in because they're like, hey, I remember how to do this from last year. So if you're like, hey, I've got 6 minutes, I bet I can finish quiz number 1, go for it, right? You are allowed to use your periodic table, all right? Did anyone not get the nice periodic table? You need one. Excellent. I'll grab you one.
Wait, we only got 50 minutes left?
And if anyone thinks they're gonna get if anyone thinks they're going to get further and you need a table of polyatomic ions, they are right here if you think you're going to make it that far over the weekend.
Can I use the washing dispenser?
Absolutely, yes. Yeah. Anyone does not have the unit 4 answer key? You can always use the old one if you want to, or you can find it. Okay. Who's looking for a 4 answer key? That was you, right? Yes. Good, good, good. Thank you. Yeah, let's do that. Oh, it should be blue and yellow. Oh, no, green and it's colors tested by the classroom and green. No. Colors tested by the classroom, red, yellow, and blue. So yeah, here's table 2 average, that's perfect. And then table 4. So what you could do is you could say this one matches that one. So you could even circle, and you did that there, that's perfect. Exactly right. Yeah. Circle on the table, right? Because, and you would say, and I would say red number, whatever it is, right? So I would say red number 2, red number 3, red number 4. Does that make sense? Yeah, but I would put like 2, 3, and number 4. That way you can say, our class red matched with red number 2, right? And you could just put it in red. Yeah. Thank you. Oh yeah, go on.
Thank you.
Yeah. It's all good. Okay. Yellow. So you would say yellow and blue. Because the green was made of yellow and blue. Oh, table 3. Okay. So green. Yeah. It look green to you? Yeah. Okay, so that'll just be blue there. And for that one, that was really yeah. Just go right there. Yeah, I'll sort everything right. Yeah, as long as it's unknown, you cover it, yellow, red, yeah, there's like blue and red, and again, you can put that that's ready for 2, 3, 4, and then you put this one, I don't care if it's 2. Okay. Yeah. Yes, yes. Okay. So we have. Okay, so you're also going to want to do, so you have, this was spot number 1, right? Maybe you want to here, 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 there. You want to do the second spot also, you want to go here, 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 here. So you'll do, you want to put this spot.
Yeah, and I'll be back in town again.
Yeah, they're separated, so you'll say, yeah.
So this will be from 2.
Yeah, so this one you're gonna have, you have orange, so you have a red, that one's probably yellow, right? So we'll figure out which yellow it is. Yeah? And this one, that's the difference in RF. Now, this distance here, 7.91, it's actually gonna be 0.6 times 7.91, yeah? Yeah. Okay. So the reason why 0.2 is not acceptable is that would mean that the solute went further than the solvent. Is it possible for the dye to go further than the solvent? No, and that's why. Okay, yeah. And let's imagine a researcher allowed this underground to develop far longer than necessary, and the solvent went to the front. What would happen is your solvent stops traveling and gets down to the bridge. These keep moving, so you end up with RON values that are too big. So you would over it. Yeah. So all you would have to do is you would have to say, in the green mixture, we determined that we had yellow dye number 2, red dye or whatever. In unknown, we determined we had this one, this one, this one. That's all. Yeah. Hi. Yes.
I'll be done before lunch is over.
Okay. Yep. Yeah. Did you want to take it over? Yeah. Sure. Yeah. Take it over. Yeah.
Just me. Actually, no, things are good. This is my if it's my location, things.
Yeah. Exactly.
TUV, everybody told me. We should rest.
Oh, wow. This one is better. Yeah. 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 Right. So. Okay. Perfect. Yeah, good. Okay. Okay. So, let's say let's say this is the crumb time. Oh, so the solvents would be like, just all these moving a little bit slower. Now, let's say the solvent gets to here, it's gonna start evaporating off. So, the solvent. Oh! Each isn't getting any bigger, but your line is getting bigger.
Oh, okay.
So you have the overestimate or underestimate? Yeah. Yeah. Yeah.
I thought that the water was over here.
I want to figure out.
Oh, yeah, yeah. Yeah, because water is evaporating and swimming in the water over its water. It is. Physics does so.
That is what that is.
Absolutely.
Let's see it.
I have $1.
Hello.
Oh, the same question. I don't think
Bro, why would you try to just
Because those that's what we're using online and you can. Yeah, so suspicious. Why do you?
Yes. Absolutely. Okay, yeah.
Oh, you're mommy.
Yes, you're right.